About lesson 2.2, and now we're looking at proving theorem 2.4, the limit of a product, and this is similar to homework number 2. Okay, suppose that we have a limit f sub 1 of x equals to L1 as x approaches a, and the limit of f sub 2 of x as x approaches a equals to L sub 2. So we have these two functions and we're going to multiply them to find the limit. So the limit of the product of f sub 1x and f sub 2x as x approaches a is the limit 1 times limit 2. So we want to prove that to be true. Okay, so our proof is we're going to suppose that for all epsilon greater than 0, there exists a delta greater than 0 such that, and then we have here f sub f1x excuse me, times f2x minus L1 times L2. Normally we have f of x minus L is less than epsilon, but here we have a product of the two. So we've proven these function minus this limit is less than epsilon whenever x, the absolute value of x minus a is less than delta. But now we're working with the product, so we have to prove that's true as well. So we can say that for all epsilon greater than 0, there exists a delta greater than 0, such that f1x minus L1 is less than epsilon over 2 whenever x minus the absolute value of x minus a is greater than 0 but less than because there are two functions instead of one. We're looking at epsilon 1 over 2 and epsilon 2 over 2, and then if we add these two together and we got epsilon, then we've proven the function. So that's the whole idea here. So we want to get from f of x1 times f of x2 minus L1 times L2 is less than epsilon to f of 1x minus L1 is less than epsilon over 2 for x minus a is greater than delta 1, and f of x2 minus L2 is less than epsilon over 2 when x minus a is greater than 0 but less than delta 2. So again, when we can get these two to add together and get epsilon is less, the product is less than epsilon, then we've proven it. Okay, so the idea here is we've got to go from a product and we've got to split it into two separate ones, and then from there we can figure it out. So here we have our f1x f2x minus L1 times L2. Okay, and we're saying, so basically what we want to do here is we want to factor this. And so the way we can do that is we know that x is x, right? So if we add a number like a and subtract a number like a, that's still x. So that's what we're doing here. So we want to factor that by, if we can come up with a common factor of f2 L1, then we can factor that out. So this is how we're going to do it. So this would be f1x f2x minus f2x L1 plus f2x L1 minus L1 times L2, and that's the absolute value. So this is equal to that. Okay, So all we did was we took this and we added F2L1 and added F2L1 and subtracted F2L1, which it doesn't change any, right? It's still the same. So now we're going to split this in half, and we're going to factor out the common factor F sub 2x from the left side and L sub 1 from the right side. So this will equal the absolute value F1. So we're factoring out F2. So this is F2 here, X. And so we factor F2 out of F1, and that leaves us with F of 1x. And factor F2 from L1, and that's minus L1. So we've gotten F1x and L1 together. That's what we wanted. Plus, and now we're going to factor out L1. And so that factor out L1 from F2, that's F2x minus factor L1 from L1, L2, that leaves us with an L2. And close that parentheses. Okay, so that's what we have so far. All right, now from here, we can use the triangle theorem of absolute value. So basically, absolute value of A plus B is less than or equal to the absolute value of its parts. Absolute value of A plus the absolute value of B. Okay, so that's known as the triangle theorem of absolute values. The sum of the parts of the absolute value. So that means this will be less than or equal to the sum. So this will be the absolute value of F2x times F1x minus L1, and then close the absolute value there, plus absolute value L1, parentheses F2x minus L2, close that absolute value. Okay, now also with absolute value of A times B is equal to the absolute value of A times the absolute value of B. So since this is f of x times the quantity of f1x minus L1, we can say that that's going to be equal to the absolute value of f2x times absolute value of f1x minus L1 plus, and now the L1 is multiplying into the quantity of f2x minus L2, so that'll be absolute value of L1 times absolute value of f2x minus L2. Okay, so from here, now we want to look at the relation with epsilon. So we're going to split this. All right, we're going to split this. And the left side, this will be the absolute value of f sub 2 x times f1 x minus L1, and that's going to be less than epsilon 1 over 2. Okay, and then this one here, the right side, we use a different color. This will be absolute value of L1 times absolute value of f2x minus L2, and that's less than epsilon 2 over 2. and that's for x minus a is less than delta 1 greater than 0, and this is x minus a, absolute value of x minus a greater than 0, less than delta 2. Okay, so here we're going to divide f2x to both sides, 2x, and we're saying 2 move over f2x, absolute value is moving in. And you can do the same thing with L1, right? L1, that's absolute value also. Okay, so here we have f, the absolute value of f1x minus L1 is less than epsilon 1 over 2 absolute value of f2x. Well, this is a problem here because as long as this is a variable here, it's y, right? Same thing as a y value. You can't control epsilon, so we're going to have to do something about that. And so, excuse me, in the right side, f2x minus L2 is less than epsilon 2 over 2 times the absolute value of L1. Okay, so we're going to address each one of these. Okay, since we want to make this a constant, so we have to address that f of 2x. Okay, since if we just looked at f2x minus L2 is less than epsilon, and so we're looking at this as any f2, not just this particular one, and epsilon is greater than 0, then we can choose any value for epsilon. So we choose epsilon to be equal to 1. We can choose any number, but 1 is easy. All right, so we're going to choose 1. So we can say here that f2x minus L2 is less than, so we're going to replace epsilon with 1. Okay, so we could use any function, f of x minus L, but because our function has f2 in it, we're going to use f2 and f2. Okay, so now let's examine, we're going to examine the absolute value of f2 of x. Okay, we're going to examine this, and we're going to convert that to a constant, and this is how we're going to do it. Okay, again, we're going to use the concept up here of x plus a minus a is just x. So we're going to do that same thing that we did with this, basically. So we're going to take f of 2 of x equals to f2x, and then we're going to apply a minus L2 and a plus L2. Okay, so all we did was we just applied a minus and a plus, and that's still just equal to f of 2x. Okay, so now we said, now using the triangle, the inequality triangle of absolute values, we said before that absolute value of A plus B is less than or equal to the absolute value of A plus the absolute value of B. And so that's what we're doing here. So that means this will be less than, this will be less than or equal to, this is less than or equal to, and we're going to split it, f2x minus L2 plus the absolute value of L2. Okay, so we're using a triangle. We're taking these two sums and we're going to split it, and that makes it less than that. Okay, so since we said that f2x minus L2 is less than or equal to 1, then we can substitute this 1 in for that. We can substitute 1, this 1, this 1 in here. So now that's going to be less than 1 plus the absolute value of L2. So we're saying that the absolute value of f2 of x is less than 1 plus the absolute value of L2. Okay, because we said this, right? f2 is equal to f of x minus L2 plus L2, split it, and then we also said up here f2x minus L1 is less than 1, so we substituted 1 in there. Okay, so this is key right here. Okay, so that's what we're going to use to substitute in for our epsilon. So now that means that when we said before, we said over here that epsilon 1 is 2 times f2 of x, right? We said that. So now we can say that f1x minus L1, close it, is less than epsilon 1 over 2, and instead of f2, we're going to put in 1 plus L1, 1 plus the absolute value of L2, 1 plus the absolute value of L2. Okay, so that means for f of x, we can substitute that back here as well. Okay, just back here. So here we have, get another sheet. So this is what we had. Okay, this is what we had when we split it. Okay, so remember here when we split our function. Okay, so that's where we're at right here. Absolute value, and I'm just going to rewrite it. f2 of x times f1 x minus L1 plus absolute value L1 times f2x minus L2. Okay, so we're going to substitute this f2 for, we said that is now this 1. So we're saying that this function is now less than or equal to, and then we're going to substitute this 1 plus L2 in for f2. So this is going to be 1 plus L1, the absolute value of L1, and then times absolute value of f1x minus L1 plus L1 times f2x minus L2. All right. Okay, so now we've got to address this side, the right side, and that's what we were doing here. Okay, so I'm just going to rewrite that. Now we're going to address this side here. Okay, and we already did part of it, so I'm just going to rewrite it. So we said, so now we're going to look at this right side. And we said that absolute value of L1 times absolute value of F2 x minus L2, close it, is less than epsilon over epsilon 2 over 2 times absolute value of L1. So we divided absolute value of L1 to both sides, right? Cancel that out. For x minus a is less than delta 2. Okay. So from here, this will be absolute value of F2 x minus L2 is less than epsilon 2 over 2 times absolute value of L1. Well, the problem here is, what if L1 were 0? Well, that would give us an undefined. So we know that we can say that if we add 1, epsilon 2 over 2 times absolute value of L1 plus 1, that is less than epsilon 2 over 2 times absolute value of L1, because the larger the denominator, the smaller the fraction. So we can say this is smaller. So it's okay to go smaller for epsilon. So now we're saying that f of 2 x minus L2 is less than epsilon 2 over 2 times L absolute value of L1 plus 1. Okay, so that means that this is going to be less than that. So that means this equation here, and I'm just going to rewrite that. So this equation will be less than this. So L1 is going to be less than L1 plus 1. So this will be less than or equal to so this is for x minus a less than delta 2 greater than 0. Okay, and so we're ready to put this all together then. So we can say that this is less than or equal to 1 plus absolute value of L1 times, I'm going to run out of room here, F1x minus L1 plus, and so this will be absolute value of L1 plus 1, because we got it from here. Where is it? Here it is. We said that this quantity L1 plus 1 epsilon over 2 times L1 is less than epsilon over 2. So that's what we're saying here, that it's this quantity is less, this equation is less than this one, times F2x minus L2. Okay, and so because F1 is, where are we? Here it is. F of 1x minus L1 is less than epsilon. We can replace epsilon over, where are we? Here it is. We can replace epsilon 1 over 2 times 2 over 2 plus L2. So this will be less than, this function, this whole equation is going to be less than this one here because this is less than epsilon. So this will be 1 plus the absolute value of L1 times, and so we're going to substitute F1x minus L1 for epsilon times epsilon 1 over 2 times 1 plus absolute value of L1 plus, and then absolute value of L1 so this is going to be, where is it? Where am I here? Oh, this is L2. This is L2 here. This is L2 plus 1 times, and then we said that F2 minus L2 is epsilon 2 over L1 plus 1. So epsilon 2 over 2, this should be L2 here, 2. This is 2, this is all 2, 2. These are all 2 here. All right, so this is absolute value of L2 plus 1. So these two are going to cancel, and these two are going to cancel. So that leaves us with epsilon 1 over 2 plus epsilon 2 over 2, and that's going to equal to epsilon, and that solves, that proves our function. For all delta, we want to choose delta be the smallest of all the deltas. And so that's it, we've proven it. That's our theorem 2.4.